Hello and welcome to today's class. Let's proceed with the study of exponential function of differentiation. Last class, we looked at the introduction to exponential function of differentiation, which I'll be dropping the link to the introduction in the description of this video. So check the description of this video. I'll drop a link to our previous class on the introduction to exponential function. Let's dive now into the shortcut of exponential function. Let's look at the shortcut to exponential function. How do you differentiate exponential shortcut via shortcut? It's easy. Let me just do a quick revision for our last class. Let's say I have y is equal to exponential x squared, for instance. Right, let me put this in a bracket. For instance, we say your first task is to call the term in brackets, call it u. So call the term in bracket, call it u. So I'm saying that u is equal to x squared. Differentiate u with respect to x. I'll have du over the x to be equal to differentiate x squared. Of course, I'll have 2x. Alright, I'll have 2x. Next up, we said from here, I have that y is equal to exponential. We just called x squared to be u. So I'll put u here. Differentiate y with respect to u. I'll have dy over du to be equal to, if I differentiate exponential u, I'll have exponential u as discussed in our last class. Last class we said if I differentiate exponential x, I'll still have exponential x. Similarly, if I differentiate exponential u, I'll still have exponential u. At this junction, I'll say using chain rule, what do we know? Dy over the x is equal to dy over the u times du over the x. From here, what's the value of the u? The value of the u is what? Exponential u. So dy over the x value will be equal to the value of the u, which is exponential u times du dx is 2x. So I have 2x. Combine this, so 2 comes first, then x follows, then exponential u. So this is my dy over the x value. But by the way, I can't express x in terms of u. So I have to take this u back to x. So but u, this u was equal to x squared from the question. So x squared. So whenever I see you put x squared, so I'll have that the final answer for dy over the x will be equal to 2x exponential. What's u? That's x squared. This becomes my answer to this particular problem using exponential function procedure. Let's now see the shortcut I'm talking about. So let's say we have this same example that y is equal to exponential n squared. The shortcut is simple. There are just 2 steps for the shortcut. The first step there, so there are just 2 steps for the shortcut. The step 1 is to differentiate the power, and step 2 is to repeat the question. Right? Differentiate the power. That's the first step. Step 2, repeat. Repeat the function. So we said first rule, differentiate the power. My power here. So by the way, I'm having y and x. So I'll have dy over the x is equal to, that is I am differentiating y with respect to x. So I'll have the x equal to differentiate the power, as we said. I'll have what? 2x. Then repeat the question. So repeat second row exponential x squared. So this is my answer. So observe this with this. Still the same thing. So said the first rule is to differentiate the power. If I differentiate x squared, I'll have 2x. Second rule is to repeat the function. Repeat the question exponential 2x. So I have this. Example 3. Let's say I have that y is equal to exponential 4x minus 2. For instance, if I differentiate this y with respect to x, I'll have the y over the x as being equal to, set differentiate the power as your first task. If I differentiate 4x minus 2, I'll have just 4. So repeat the question as exponential 4x minus 2. This becomes my answer to this particular question. This is how I solve shortcut. Let's say I have that y is equal to exponential 15x, 15x minus 2x. For instance, still easy to do. What do you do first? I am writing y with respect to x. So I have the y over the x as being equal to differentiate 15x minus 2x. So I'll have 15 minus 2 after differentiating. Then repeat the question exponential 15x minus 2x. 15 minus 2 is of course 13. So I'll have 13 exponential 15x minus 2. So this I solve, minus 2x. So this I solve problems involving shortcut of exponential function. So see you in the next class. So we're looking at the logarithmic function of differentiation.